Hi, the purpose of this demonstration is to solve a polynomial inequality. Now, what is a polynomial inequality? Well, basically, it is a polynomial, which this one is, that has an inequality in it, and we're going to solve it by graphing it. Okay, we're going to express the answer as a graph. All right, let's get started with this. I have two options. I can change this to the standard form, where it's ax squared plus bx plus c is less than 0, or the vertex form. I'm going to use the vertex form on this. Let's see if we remember what the vertex form is. It's a times x minus h quantity squared plus k is equal to, and in this case we're going to say just less than or equal to 0. So let's change this to this form and get all the information for our graphing from that. All right, moving back to my original problem, x squared minus 2x plus something is less than or equal to 2 plus something, because remember the vertex form uses completing the square. Moving on, to complete the square I'm going to take half of this and square it. Half of negative 2 is negative 1, negative 1 squared is 1. So I get x squared minus 2x plus 1 is less than or equal to 2 plus 1. Now the factored form of this is x minus 1 quantity squared is less than or equal to 3. Almost done here, because I'm going to move the 3 over here. X minus 1 quantity squared minus 3 is less than or equal to 0. Now notice that this form follows exactly this form with just a couple of differences between the pluses and the minuses. Okay, now what does this tell me? This tells me that my a, which in this case is a 1, the number in front of there, is positive, so that my parabola opens in the upward direction. This tells me that my vertex, and this is why I like this form, is actually 1, negative 3. How do I know that? Well, the x value is whatever makes this equal to 0, so it's 1 minus 1. The y value is just what we call the k up here, so that's just negative 3. So there's my vertex. How easy was that? Now, what are my x-intercepts? My x-intercepts are, I basically have to go up to here now and solve the problem. Okay? So I've got x minus 1 squared less than or equal to 3. Let's take the square root of both sides, and I get x minus 1 is less than or equal to the square root of 3. Let's get the 1 to the other side. I get 1 plus or minus the square root of 3. So my two x values are x is equal to 1 plus radical 3 or x is equal to 1 minus radical 3. All right, almost done. My y-intercept, again, is basically equal to just whatever the c value is. So I'm just going to move the 2 over here, and it's going to be x squared minus 2x minus 2 is less than or equal to 0. Minus 2 is my y-intercept. Okay, so let's look at my information now. I know my vertex is 1, negative 3. I know one of my x's is 1 plus radical 3, the other one is 1 minus radical 3, and my y-intercept is negative 2. Let's go ahead and graph that and see what it looks like. Okay. To do a quick sketch of this, my vertex 1, negative 3, so we're going to put that right there. 1 comma negative 3. My y-intercept is at negative 2. Let's put that right about there. 0, negative 2. 1 plus radical 3. Now radical 3 is about 1.7, isn't it? So 1 plus 1.7 is about a 2.7. That's right about there. 1 plus radical 3 is 0. And that's 1 minus 1.7, so about a negative 0.7. That's right about there. And that works actually perfectly with my parabola, doesn't it? And it opens upward. So 1 minus radical 3, 0. I'm not done though, because now what I've done here is I've divided my x-axis into 3 regions, and it's divided by the x values. So what I need to do, because I want to graph this, I want to test an x value from each one of these 3 regions, okay? Let's try a point from over here and let's put it into the equation and see if it works. Now we said this is about a 2.7 or so, so let's try 3. So we're going to test the point 3. If I put that into the equation, I get 3 squared minus 2 times 3 is less than or equal to 2. That's going to give me 9 minus 6 less than or equal to 2, or 3 is less than or equal to 2. That doesn't work, does it? That means that none of these points will actually solve my equation, so I can't graph anything there. Let's try a point between these two parts here. Let's try 0, because that's a good point to choose. So we're going to test 0. Okay? I'm going to get 0 squared minus 2 times 0 is less than or equal to 2, or 0 is less than or equal to 2. And that's a true statement, isn't it? That means that any point in between these 2 points, anything in here, is actually going to work. And you can just test that for yourself if you'd like. All right, moving on. Now we need to try a test point on this side. And again, we said it's about a negative 0.7, so let's just try negative 1. Test negative 1. Inserting that into the equation, negative 1 squared minus 2 times a negative 1 is less than or equal to 2. That gives me 1 plus 2 is less than or equal to 2, or 3 is less than or equal to 2. Again, doesn't work, not shaded. Now that's great, because what we've done is we found all the shaded parts along the x-axis. Now let's find it along the y-axis now, okay? And that part's actually fairly easy. If you go back to your original equation, x squared minus 2x is less than or equal to 2, and move the 2 over, I'll get x squared minus 2x minus 2 is less than or equal to 0. That's telling me that all my y's, because this is just equal to y, needs to be less than 0. All right? All my y's, because again, this is just equal to y, right? All my y's have to be less than 0. That means I'm going to choose all the y's below 0, not the ones above. All right? So I'm going to get to shade all those y's that are below 0. And that is my answer. If you want to check, just choose any point out of there and insert it into the equation. You'll see that it actually ends up working. All right, good luck with this.